Good morning, I'm Bonnie Gardner. I'm co-chair of the Public Affairs Forum of the First Unitarian Universalist Church of Austin. We're located at 4700 Grover Avenue. Our forums are most Sundays at noon, and they're free and open to the public, and we encourage you to attend. Our mission is to nurture the mind and the spirit and serve social justice. Today I am honored to be introducing Dr. Kent Stewart, who's going to be speaking on GMOs, the latest step in a long history of selective breeding of food. He's truly an expert on this topic. He's going to talk about a history of plant and animal breeding and an overview of all the science behind the use of GMO species as food materials. He's going to address concerns about safety issues which have GMO components. He studied at University of Chicago and UC Berkeley, where he received a degree in chemistry, and then he was in the Marine Corps as an officer for 3 years. Then he went on to Florida State University, where he earned a PhD in chemistry and did a postdoctoral fellow at Rockefeller University in New York City. He is a professor emeritus from Virginia Tech. He is an analytical biochemist who taught at a number of universities, including University of Texas at Austin. He's listed in Who's Who in America, the International Directory of Distinguished Leadership, and American Men and Women of Science. He was a member of the ad hoc panel on criteria for determining the regulatory status of food and food ingredients produced by new technologies in 1988, and this was one of the first committees established to evaluate the safety of what we now call GMO foods. And Dr. Stewart is a member of our church, and we want to give him a very warm welcome. Ken, thank you.
Today I want to talk about GMOs, and I want to talk about the science and the safety. I'm not talking about the politics. I'm not talking about the religion. I'm talking about the science and the safety. But I want you to know what natural looks like. We have up the upper left, watermelon. In the middle, corn. On the right, carrots. On the bottom, bananas. Could we focus that a little bit? Eggplant and broccoli. These are not what you see in the market today. The history of modern-day maize, corn, begins at least 10,000 years ago, and humans have been doing selective breeding of corn since that time. These are corn cobs found in various caves in South America. They're basically fossils, and as you can see over the time, there's an enormous change in growth in the corn. More maize is harvested every year than any other grain, and most of these varieties are done by human breeding. The auroch was first domesticated someplace like 8,000 to 10,000 years ago, and they're believed to be the ancestors of modern dairy cattle. There are now over 800 different breeds of cattle. One of the dairying activities in Europe began and developed the Holstein about 6,000 years ago, and two comments I wanted to make. Number one, these animals cannot live in the wild. They have to be milked every day or they die. The second one is that this was such a common adaptation that all of us from Northern Europe have a modification of our genome so that we can tolerate lactose. It's a result of the selective breeding. This is a panel of an Assyrian carving from 870 BC showing artificial pollination of date palms. So in traditional breeding, what do? You look for valuable traits in plants and animals in breeding trials. Such traits arise occasionally, but quite rarely, They're spontaneously through a process called mutation. The natural rate of mutation in plants and animals is actually quite slow, and so it's often they don't produce the traits we want to see in our foods and plants. Selective breeding does, most of the time it doesn't do anything useful. It's not helpful. Sometimes you get a good trait that you're after and you're able to transfer it to the gene you want. Sometimes you get a bad trait and transfer it. And as a matter of fact, I know of 2 cases where in breeding of plants, we created a toxic foodstuff and they had to make sure that never hit the market. Breeding across species. Most cross-species offspring do not survive. They die. They never make it. Some have sterile offspring. The one most of us know about is the mule. The male donkey female horse. The male donkey has 62 chromosomes. The horse has 64. The mule has 63, and it doesn't work. They're good animals, but they don't breed. Sometimes, rather rarely, you get a new species. Killer bees that we have in Texas are supposed to be a cross between 2 other species of bees that survived. After World War II, they realized that radiation would give them mutations, and there was a very active program in creating new mutants with X-rays or gamma rays. And from 1930 to 2014, 3,200 mutagenetic plant varieties were released and used for foodstuffs. I would note that plant mutations produced by radiation do not contain any radiation. The point of these slides is that with modern domestication, plants and animals, we are a very long way from wild types. The changes have come out primarily through selective breeding by human efforts. I would like to suggest that the plant and animal breeding done by humans is a genetic modification that we've been doing for thousands of years. We just didn't call it that. This is the tree of life. Now, I'm a biochemist. The point of the tree of life is, from a biochemical point of view, we're all the same. Whether we are a neuraspa, a baker's yeast, a chimpanzee, a sunflower, we have all the same chemical compounds. We have the same amino acids. We have the same sugars. We have the same fatty acids. We have the same vitamins and growth factors. Now, those of you who are expert in this area will know there is a small percentage of one bacteria type which people believe might have come from outer space. It is certainly different than everything else, but it's a very small percent of the total genome of the world. Because we're the same, we can eat other species. We can get our nutrition from other species because their amino acids are our amino acids, etc. We have the same classes of proteins. We can map genetic progress of new proteins. We have the same classes of enzyme activities. We have the same metabolisms. We have the same metabolic cycles. We have the same cellular organization. We have the same genetic code. We have the same protein synthesis. So, biochemically, which very much well fits with this church, we're all one. Genes are the biological code books for determining the characteristics of living systems. Human beings have 20,000 genes. Rice has 40,000. Maize has 50,000. There's some things that have more than that. Traits are transmitted by sex. Half of the DNA from the genes comes from the male and half from the female. That means that every time a seed or an egg is produced, it gets a full complement of genes from each parent, which is why it is so darn hard to make the genetics of what you want, because every time you breed something, you get both sides, and whichever one wins out dominates. So, humans, you get 20,000 from your mom and you get 20,000 from your dad, and let the best gene win. Mutations caused by cosmic rays, and you and I are living with cosmic rays that are passing through us now at an astronomical rate, and you don't even know it, except I have a small mutation on my thumb. X-rays, radioactive materials, UV light, and a bunch of chemicals. Actually, the number seems to be approximately half of all the organic chemicals that we know of have potential to be mutagenic. Mutations are routinely found in various species. You saw the pictures of the corn. Every single seed was a different gene pair, and they're very common. What happens in mutations? First one, most common one, is cells die. They have this lethal mutation, and they can't reproduce. Sometimes the protein is altered. I'll go back into that. You get the same activity, but it's modified. Or you get a new activity, but that's kind of rare. Or the amount of protein produced is changed. Genes are made of DNA. DNA is the code book for life. The information flow in your cell, DNA produces more DNA like itself. DNA goes to RNA, which is then transported to the protein synthesis area of the body, and we make proteins. That's what mutations do. They make what DNA stuff does, for the most part, is make proteins or code for proteins. There's a small exception to that, but it's not important today. So, this is the dogma of information transfer in biology. DNA goes to RNA, goes to protein. If there is a mutation in the DNA, then there's a mutation in the RNA, and then there's a mutation in the protein. Proteins are the machinery of life. There are muscle, there are skin, there are bone structure, there are hair. They synthesize protein structures, vitamins, minerals, carbohydrates, and other biochemicals. They digest proteins to amino acids, fats to fatty acids, starch, cellulose to sugars, etc., etc., etc. They have other functions. So, you and I, who have different traits, have different proteins, or different amounts of a protein. If a trait mutation occurs, then what actually occurs is the protein is modified either in activity or amount or both. Proteins are composed of one. You're getting a very quick lesson about chemistry. Proteins are composed of one or more linear chains of amino acids. There are 20 different amino acids. The sequence of the amino acids in a protein determine its structure and function. This is a picture of different insulins. All of these activities, insulin, but the different colors are for different species of insulin. But, as in many cases, the hormone insulin that works in one species does not always work in another species. This is true of almost all the hormones. Something that works for cows may or may not work for us. And as a matter of fact, two of the things up here are totally synthetic insulin, not made by any species. I would remind you that when you eat protein, it's digested in the stomach, the small intestine, to amino acids. Extensive studies, sequence of amino acids, determine its function, its control of its function, its stability, and its immunochemistry. A mutation, then, means either the protein's not made, or a different amino acid's inserted into it, and you either have its function changed, or its stability changed, or its control function changed, or some combination. The classic experiment done by Linus Pauling many years ago now, there's a disease among African Americans called sickle cell anemia, and Linus Pauling did an amino acid study of these things. The difference in these two hemoglobins is one amino acid. One amino acid difference takes you from a normal functioning human red blood cell to a hemoglobin back to a sickling red blood cell. That's just one amino acid per change. That's how much impact a mutation can have. So, the code for amino acids is 3 letters of the DNA. And there are also start and stop codes, and any of you who do statistics will realize that gives you 64 possible combinations, and those are the codes for making proteins. If the code is changed and the amino acids are changed, and then the protein is changed. All living things have the same amino acid code, with the exception of that little group I told you all this time. Everybody has the same coding. You, your dog, your banana plant, all have the same code. Your yeast. This suggests that organisms' protein production machinery doesn't care about the source of the DNA. That's true. That's been shown many, many times. So, your protein synthesis material doesn't care about the DNA. The E. coli synthesis material doesn't care where the DNA comes from. It makes what it's told to make. This suggests that you can take a biological function from one species by getting its DNA and inserting into the genome of another species, or another variety of the same species. And this has been done many, many times. New genes are new sequences of DNA. So what do? Well, we isolate, we find a trait we like. Hopefully in the same species, but we find a trait we like. We isolate that DNA. Or we can synthesize it in the lab. There are DNA synthesizing machines that sell. You can probably buy one and put it in your garage. They're getting fairly cheap. The geneticists won't like me, but as far as I'm concerned, genetics is just a special type of chemistry. It's just chemistry of bonding of base pairs, etc. Okay, finally to the topic of the day. GMOs are defined as foods produced from organisms that have had special changes introduced to their DNA by methods of genetic engineering. The common methods are turning off a gene or inserting a new gene. If you turn off a gene, you have one less protein. If you insert a gene, you have a new protein. First ones done were flavor saver tomatoes, where they turned off the gene for ripening so they could ship them. This caused all kinds of hubbub, but they had made tomatoes, which quite frankly didn't taste very good, but they made tomatoes that could be shipped and then ripened to the shelves. This is what started all of the hubbub. And they were quite safe to eat. This is what started the committee that I was on. They were a commercial failure. Nobody cared. Insect larvae, are a primary cause of loss to farmers. They eat everything. Anybody who's ever worked on a farm, I grew up in Iowa, I remember seeing the corn borer eat half my corn from stuff. And it's a huge problem. Huge amount of waste. BT thuringitis, commonly what we call BT, is an insect protein which is marketed worldwide for the control of many important plant pests. Mainly caterpillars, butterflies, and moths, but only in the larvae. BT doesn't bother anything but larvae of insects. They make this into powder and they spray it on the fields. They've been used extensively for 50 years. It's considered safe for humans, mammals, fish, birds, and the environment, because the only thing it does is the guts of caterpillars and butterflies and moths. Doesn't do anything else. These products have a very good safety record, and they can be used on many crops until the day of harvest. Well, this is kind of a shotgun approach. You spray the whole field with BT and it all over the place. Kills any larva in sight, on or off the field. So what they did was they took the gene that made the BT protein and they inserted it into the genome of corn. This way you don't have to spray it. The plant makes it. When the larva eats the BT-containing cells, it dies. So you don't have to spray it. So that's a serious reduction in the amount of spraying that is required of this product, which obviously helps the environment. Bovine growth hormone is a small protein and bovine growth hormone is made synthetically. They isolate the gene that made bovine growth hormone. They grow it up in bacteria and purify it, and they inject it into dairy cows. This increases the production of milk for someplace between 10 to 15%. The use of recombinant bovine growth hormone on dairy cows was approved by the Food and Drug Administration in late 1993 and has been used since 1994. Now, one of the causes of human dwarfism is the lack of sufficient human growth hormone. And it used to be that the only way you could treat these people was to isolate human growth hormone from cadavers, which is very expensive, and you didn't get very much. Now, I'm a soccer fan, and those of you who are soccer fans will recognize this as Lionel Messi, who's probably the most famous soccer player in the world. Well, the reason I put him up here is because he was too small to play soccer. He had magnificent skills, but he was small, and he would get crushed on the field. So they gave him a treatment of human growth hormone to let him grow. He's still one of the smallest players out there, but at least he's now big enough to do this. The growth hormone from other species does not work in humans. And even if it did work in humans, you have to inject it. So if you eat it, it gets digested. So I think the controversies surrounding the use of bovine growth hormone in milk production are political and philosophical, not safety. In 2007, 216 million metric tons of soybeans were produced globally, a primary source of protein and oil to world population. At that time, 56% were GMO. Weed control is a huge problem in soybean production. And the cost of weed control is a huge cost in raising the crops. So for some time now, Roundup has been the weed killer of choice. But it kills almost all the plants. Almost any broadleaf plant out there, it will kill. So Roundup is now being used in the present form for about 25 years. And no cases of human toxicity or cancer swarms have been found. And I would point out that the CDC of the United States is astoundingly good at picking up disease states that pop up someplace. Given that there was an article about Roundup in the newspaper recently, I expect questions. Monsanto inserted a gene that makes plant crops resistant to Roundup. Actually, they got the gene from soybean. They found a mutant soybean. It wasn't much good for anything else, but it resisted Roundup. Now it meant you could use Roundup as a weed, could be used as a weed control agent without harming the plant crop, significantly reducing the cost of raising the food crop. One of the interesting side effects of this is you don't have to plow anymore. You don't have to plow and harrow. You can do what they call no-till farming. You kill the last year's crop, and then you just insert the seeds in the ground, and you spray everything else. Nothing else grows, but the soybeans come along just fine. This drastically reduces land erosion. If you don't have to plow, the plowing and harrowing of the crops are a huge cause of land erosion. Roundup-ready GMOs have been proved for soybeans, corn, cotton, alfalfa, sorghum, sugar beets, and canola. To say a few, I'm sure there are a few more out there now. Vitamin A deficiency is a huge problem in much of the world. So lack of vitamin A causes severe visual impairment and blindness. In ancient days, it was a serious cause of blindness. It significantly increases the risk of illness and death from childhood infections such as diarrhea and measles. A pregnant woman, particularly in the last trimester, the child will get most of her vitamin A, and she frequently get night blindness or vitamin A deficiency. It's very high prevalence in some of the world because of this night blindness. You can overcome it by going breastfeeding and vitamin A supplementation, but the long-term solutions require vitamin A-rich diets and food fortification. The impact of vitamin A supplementation on child mortality is as great or even greater than many of the vaccines against disease. The impact of having a proper vitamin A supplementation for the population is huge on mortality. Now, there's a little problem here. The green spots are the places where there's not much vitamin A deficiency. The red spots are the places where it's endemic, a serious problem. And the orange are the ones in between. What I'd like to point out here is the people who make the rules about these things tend to come from the green countries. Golden rice was developed several years ago because they added 3 biosynthesis genes to the rice genome so that the new proteins could synthesize beta-carotene in the rice, and beta-carotene is then changed into vitamin A in the human body. In 2009, the clinical trial of golden rice, the American Journal of Clinical Nutrition concluded that beta-carotene derived from golden rice was effectively converted to vitamin A in humans. They suggested the research was that golden rice could provide 50% of the RDA, vitamin A, from maybe a cup of rice, leading to enormous potential reductions in mortality and night blindness. The issues for golden rice are this. These are the people who need golden rice, the people in India, the people in Africa. The people who make decisions are bureaucrats at the UN and the United States who don't have any vitamin A deficiency. They don't have any kids with vitamin A deficiency. The doctors have probably never seen night blindness. And the chefs. The chefs are very proud of what they do, but I really admire their work and food, but sometimes they don't know very much nutrition. So, GMOs have one less protein, a new or different protein, those proteins are converted to their constituent amino acids in their stomachs and small intestines. So what are the issues with the current GMO foods? Science, safety, and I'm not a politician. I'm not going to talk about the politics. I'm not a religious leader. I'm not going to talk about the religious issues. I'm not a philosopher. I'm not going to talk about the philosophical issues. Although I might try to answer questions. As far as I'm concerned, the potential safety issues from GMO food materials, and they're there, are the same safety issues for the food materials that are produced by the more traditional breeding processes. I told you about the 2 toxic plants that I know of. The spraying goes on whether or not the plant's GMO. So, what are the safety issues? Obvious safety issues, things we identified way back in that first committee. Food allergies. Can you transport an allergic protein from a peanut to something else? Yes, you can. It has been done. Can you make a toxic protein? Bruce Ames, the famous biochemist at Berkeley, said, plants cannot run away, so they conduct chemical warfare. There are almost every plant has toxic proteins. There are some proteins, like ricin, which is extraordinarily toxic. It comes from castor beans. There are a lot of naturally occurring toxic materials. They can be translated. You can transport those into a new genome. So, what do? Well, you don't allow those genes to be used in the system. You have to say where you got your gene, and you have to show that that's a safe source. Require feeding experiments on all new ingredients. And one that I loved, a friend of mine said, and every CEO of a new genetically modified plant has to be willing to feed it to his grandchildren. So, the issues with GMO politics, many of the value go to the producer, and not as many go to the consumer, which I think is one of the big problems in the politics of the issue. There's a lot of fear-mongering going on. There's a lot of fear. I don't understand it, therefore it must be wrong. Quite frankly, the public knowledge of science is abysmal, and most people seem quite happy to have it stay that way. There has been, in the last 20 years, a serious erosion of public's trust of experts. So much so that I know of people in my own family who trust the internet more than their doctor, which is just crazy. Thank you for your attention. When you ask a question, I will try to answer it, or I will give you a dumb look and get back to you.
We have a question from Russell SQ. Would you stand up?
Hi. I am concerned about bees. Bees are dying off because of genetically modified organisms.
My understanding, I agree with you, the understanding is that bees are dying off. I don't think they quite know why. I've heard a number of hypotheses. I've never heard anybody agree on them. But if you use BT in the corn, does it make any difference whether you spray it or put it in the corn? And both ways kill bees. There's not any difference in those two systems in that. Does that answer your question? Okay.
We have a question from Gary Bennett. Gary?
Okay. I'm going to toss one of those philosophical, political type questions at you. And that is, do you think that these genetically modified organisms should be patentable?
That was not my issue. The U.S. Patent Office and the Supreme Court settled those issues. I am puzzled by some of their decisions. I don't think you should patent genes, but obviously the Supreme Court disagrees with me.
Dr. Stewart, My question is related to your discussion of growth hormones. Cancer is basically runaway growth of cells. Do you believe there's any correlation between use of growth hormones and increasing cancers?
Do I believe there's any relationship between increasing use of growth hormones and cancer? I don't think so, because well, my wife just died of cancer, as some of you know. The medications used never targeted a growth hormone. I have never ever heard anybody of the various and the sundry oncologists we met during the last 7 years mention growth hormone. So I'm not a medical person. I don't know the answer to that, but my guess would be no.
Not so much a question, just a short statement. I have a German scientist who's been living with me from my laboratory for a few years. She tells me that all GMO products in Germany are now forbidden.
She comment was that all GMO products in Germany were forbidden. I believe that the whole European Union is against GMO products as a political issue.
We have a question from Jim Bryce.
Yes, thank you very much, Doctor. My question is a more general question. That is, with respect to agriculture and what you were showing here, where we have fields of corn, GMO treatment, etc. We have a situation in which we may be limiting biodiversity, and GMO might drive us even more in that direction by making it even more and more and more profitable to simplify the environment. What, in your opinion, are the long-range issues surrounding perhaps a drop in biodiversity?
Well, that's a little bit far afield from what I know. The best system I've seen for biodiversity is seed banks. Most of the countries in the UN and the agricultural branch of the UN have seed banks. We have been on monoculture for about 100 years in the world. The good news is we don't have massive famines anymore except by wars. The bad news is we have lessened our biodiversity, and that's a problem. I don't think this will have much to do with that. We were into monoculture and corn production and soybean production and rice production well before GMOs came in. I don't know. The production of GMOs has decreased the cost of foods, and that we've fed people over the world. When I was a boy, we always heard about famines in India and China. It's been a long time since I've heard about a famine in India or China.
We have a question from Joni Gelton. Would you stand?
Yes, thank you. What do you have to say about the farmers who are being sued for having DNA on their land? In other words, they're being sued for having seed that the corporations are saying they are reusing, and in some cases they are being sued by corporations even though they never bought the seed, and the DNA came onto their land unknowingly, and they didn't actually want it. They were actually trying to be organic, or they were trying to be non-GMO, but wind and animals and things brought the DNA onto their land, and then they are sued for hundreds of thousands of dollars, and in many cases it's enough to really destroy their livelihood.
The case she's talking, there are a number of cases of this where the pollen from the plants have come across fields, coming into fields that were not GMO, and the GMO seeds then took place there, and then the farmers replanted the seeds and got sued and lost in court. Number one, I was really surprised at that decision. That's a legal system, and I don't understand it. The other issue that has been frequently brought up to me is you have to buy new seeds every year. Well, that started in the United States in the 1930s with hybrid corn, because the corn you got from hybrid corn did not breed true, and it reverted to its original seed species. we have had a process for a long time of not being able to use the food seeds that were grown for food as seed crops. But that decision just astounded me. I was very surprised.
We have a lot of time for questions, so I know there are more out there. Be sure to raise your hand so I can see you. Douglas Bauer?
Unrelated to my last one. Some of the food companies now are advertising that they're making products without GMO ingredients. An example, General Mills recently announced that Cheerios, the iconic brand, is being done GMO-free. My question to you is, and they're also saying that these are just because of consumer demand and they're no different than the regular products. My question to you, is there really anything that can be considered GMO-free at this point?
You have three questions there. First of all, is there anything considered GMO-free? I haven't a clue. Secondly, there are two separate issues with ingredients in foods. If I isolate soybean oil and sell soybean oil for the many things that it's used for, it doesn't have any protein in it. Therefore, the protein that came from, whatever protein came from the GMO system isn't there, because there is no protein in oil. Ditto variety of sweeteners. The second question is, why do people do this? Quite frankly, I don't know. I have some theories. One of them is we have an astounding, terrifying rate of scientific ignorance in the country. We also have a number of people who make a living scaring the hell out of you in a lot of areas, not just in foods. And the food companies and the seed companies have had awful human relation programs. They have just been awful. They have annoyed the heck out of a lot of people, and we saw this way back when we were meeting. So, three things: lack of scientific knowledge, fear-mongering on a major scale, and pretty poor public performance by a number of these companies. Monsanto is yin and yang. Monsanto deserves enormous credit for coming up with a system which increases our food production and our amount of food we can get and the cost of the food. They are not pleasant people to deal with. So, take your choice. Did I answer your questions? Thanks.
We have a question from Richard Halpin.
Well, Dr. Stewart, thank you for your sharing your scientific wisdom with us today. Clearly, you're a bright guy, and you've had a lot of experiences. Can you hear me?
Yep.
I want to make sure you heard the bright guy part, because I know that will bring a smile to your lips. So my question is, if the whole European Union has outlawed GMO-related foods, you being a bright guy and having a lot of experience, what's your take on that? Why do you think they've done that? It certainly can't be because they don't have scientific minds, or they're fear-mongered, or whatever it is. What has that whole group of countries made that decision based on?
I do not even pretend to understand what drives the politics of the United States, much less the politics of Europe. I think part of this came out from a very early use of the word Frankenfoods. And everybody knew who Frankenstein was, and if you named it Frankenfoods, I think they assumed it would be bad. Also, Europe produces an excess of food. They do not have starvation problems other than places where the economy has gone south for another reason. So it's not a big deal to them to have vitamin A supplement in food. It's not a big deal to them. Matter of fact, they don't like competition in their agriculture. They subsidize their agriculture heavily, even heavier than ours, which is quite a surprise. So they don't have any particular desire to like it. But really, I really don't know why they did it.
Well, again, not a question. A small comment relating to what you said before. I believe sickle cell anemia evolved in Africa. If you don't have this, if you have normal blood cells, a large number of people over there die from malaria every year. If you have sickle cell anemia, if you are heterozygous, you're immune to malaria. If you have homozygous for sickle cell anemia, you die.
That's correct, as far as I know. There are a lot of genetic materials, genetic systems that work very well in one environment or ecology, and they do not work very well in another ecology. The example would be those cultures which have high starch, very low simple sugar. They don't have much trouble with diabetes, but when they go into a high sugar diet, they start having major troubles with diabetes. There are a number of cultures like that around the world. Just because your genome works in one environment doesn't mean it will work in another environment.
We have a question here. Would you stand and say your name, please?
I'm Paulette Delahousie. Actually, I have a book recommendation because it's got a very balanced look at GMOs and a lot of other things. The book is called Just Food. He's kind of a local guy. I think he teaches at Texas State. His name is James McWilliams, and I think that's a wonderful book. And it has a balanced view of that and several other things.
Thank you for that information.
We have a question here. Scott Johnson.
Good morning, or good afternoon. When you were talking about, Doctor, about the idea that there was an imbalance in terms of food production and that GMOs have helped fully or partially fill that void, I would take issue with that and ask you to explain where we were, and in a specific example, where we were in India and China and where we are now and how GMO crops have filled the void, please.
China, when I was a boy, China was in political turmoil, but China has a long history of massive famines. Part of it's due to distribution, but also and marketing techniques, but also part of it's just due to not sufficient production of food. I'm trying to remember, my son gave me a book in the 1980s. I'm trying to remember the name of it. Anyway, he said we were going to be in the disaster by the year 2000 because of the lack of production of sufficient food. 2000 passed, and it never happened. The ability to increase the food production has been one of the great scientific achievements over the last 100 years, and both in quality and in quantity.
We have a question from Jim Bryce again.
What I'm hearing you say, Doctor, is basically two benefits. One benefit is the benefit of situations such as providing vitamin A.
Okay.
The second benefit is an economic benefit, providing increased production at a lower cost, which of course deals with the issue of famine. But alongside that is the issue of an illustration you gave a moment ago in which you had fields in which the larvae of insects were intentionally poisoned by first the application of an insecticide and then a GMO-produced plant. Sounds like a good idea, except when we have a situation in which we see a lot of our species disappearing. I'm thinking now of the questions surrounding the disappearance of the monarch butterfly. Are there issues surrounding that with these changes, and perhaps is there a better direction to go?
There are certainly a number of issues involved in loss of species. But my point is, my discussion is, this is not a GMO issue. It might be an agricultural issue, and you have a very difficult balance between production of enough food to feed people and the environment. And I don't think we've done a very good job on that. But I don't think that is I came to talk about GMOs rather than the issue of environment, but I don't think the use of GMO plants has much of a feature one way or the other in that issue. The issue of production of food is a huge one, and for a while we were doing pretty well, but my understanding is the last couple of years we're very close to a tipping point of not producing enough food. The population of the world is growing at an astounding rate, and we're working very hard to keep the food production up, but I'm not quite sure. My understanding is they're not quite sure. Global warming, drought in California, floods in India, that might take us back into famine again. I really don't know the details of that.
We have a question from Shirley Weiler. Shirley?
My grandchildren have a phrase that I've never heard in my childhood. Their phrase is that gluten? It's got gluten in it. It's like, where'd that come from? Have GMOs had something to do with modification of wheat that's caused what seems to me to be an explosion of gluten sensitivity, or perceived gluten sensitivity at least?
Have GMOs had something to do with, I can't think of the name. Rachel, help me. What's the name? Celiac disease. Celiac disease. I don't think so, but I don't know. But we have been doing wheat as a primary grain in Western civilization for about 10,000 years. A lot of people didn't know they had celiac disease until fairly recently, but most of us don't. Gluten-free foods are good for, 10% of the population or less?
We have a question here.
Yes, Joni Gilton again. It sounds like your belief system is such that given what we know about chemistry and biology, that humans might be actually more knowledgeable than Mother Nature in terms of the creation of life and the creation of this web that we have, this connection with all living things. That Mother Nature, as we, let's say, watch nature shows, we see the intricate connections between living things, so the symbiosis and just all of the different relationships. And it seems my understanding of science has to do with focusing on one small part. And it seems like you might believe that human knowledge, or that humans might be more smart than Mother Nature. Do you think that's true?
No. Mother Nature isn't smart or dumb. She's random. Genetic production of systems is random. I want to remind you of natural foodstuffs. That's natural foodstuffs. That's what Mother Nature produced without our intervention. Now, we have made enormous numbers of very stupid mistakes. I do not think we're really good at that. I think it's really crucial that we maintain gene banks around the world so that we have these genetic things available to us. The best chemist I know is Mother Nature. What she does in plants, organic chemists are still working to catch up.
We have about 5 minutes left. This is a question from Russell Eskew.
Dr. Stewart, it's not enough to say that we don't know why the bees are dying off. We have got to save the bees.
I'm sorry, didn't hear the last part.
We have got to save the bees.
I totally agree. We have to have bees. But the last theory I heard was that the bees were caused by a parasite. But I don't think we really know. I haven't heard any indication that we know why the bees are having trouble.
Do we have any final questions? Yes, Carl.
Thank you for speaking. So my question is, what is the appropriate relationship between the chemists who are doing the discovery and the food producers to ensure that the best GMOs are selected for usage?
I don't know what the best relationship is. I do know that the food industry, like all other industries, makes or sells what they believe people want to buy. They really don't care. If they can produce it and sell it to you, they really don't care what it is. There are some exceptions to that, but by and large, the industries are in the business to make money and sell a product or give a service. And if you don't want GMOs, fine. By the way, I don't care whether or not you guys want to do GMOs. I am not an advocate for GMOs. I'm not an advocate against GMOs. This is not an issue that concerns me, but what I am worried about and have seen is an enormous amount of fear-mongering and ignorance which has caused response systems which I do not believe are accurate facts. That's why I did this talk.
I think we have time for one more question. Would you stand and say your name?
My name is Judy Davis. I'd like to know why you chemists haven't spoken up and gotten more involved with the states that have tried to say no GMOs in their state. I've seen that in a couple of states going on in the legislature, and I feel like it's truly political. But why haven't the chemists and the biochemists come to the table?
They have. They have for a long time. But scientists, by and large, are lousy public communicators. They assume too much. They use too many acronyms. They use too many initials. And they believe, by and large, as I believe, that it's the job of the scientists to get the knowledge, to understand what's going on, and to present the options. It is not their job, although I disagree with this, in fact, Bart, to handle the politics. I have appeared in front of a couple of political committees. It is extraordinarily unpleasant.
Well, if you would like to take a minute to make a concluding statement, we'd love that.
I hope what I've done today is to give you a perspective from what I believe is a scientific view of the safety of GMO. I hope I've given you an understanding of what process they go through and what to compare them with. They do not stand by themselves alone. You have to my viewpoint, you have to compare them to the traditional agricultural processes that do not use them. I thank you very much for coming and for being such a polite audience.
Thank you. Thank you for the scientific straight talk. I think we need it.